Alright, here we've got a vane-type cartridge oil pump. It's a positive displacement unit, but right now it's not running. My guess, the vanes inside might be jammed, or maybe there is something else going on. Let's crack it open and take a look.
Hey everyone, welcome to Yukamai. Science has proven that when you solve a tough problem like cracking a tricky mess or physics equation, your brain releases a surge of dopamine and serotonin, stronger than any known drug. Now picture that same high when you open up a mechanical system, figure out how it works and fix it with your own hands. It triggers the exact same reward in your brain, sometimes even more intense. That clarity, that rush, it's real. Stick around, we are just getting a start. And if you're into this kind of deep dive, hit the like and share it with someone curious. And remember, you can make it.
As you can see here, the first thing we run into is a spring. It works both as a vibration damper and a pressure relief mechanism. If the outlet gets blocked for any reason, the spring lets the plate shift a bit and allows the oil to bypass. Without that, pressure could build up and cause serious damage to the components. This is the inlet plate of the pump with two main ports designed to let fluid into the cartridge and small equalizer holes helping balance the pressure. And finally, these two guide holes aligned with the positioning pins keeping the inlet plate firmly in place. This is the main part of the pump, the cartridge itself. The engineer cat is here, and now as you can see, the vanes inside the cartridge are completely stuck. They are supposed to pop out easily under centrifugal force when the motor is spinning, filling the camring and moving the oil through rotation. But right now they are not moving at all, whereas they are supposed to move easily. Even when I shake it, nothing. Alright, this is the camring, also known as the pumping chamber. It has an elliptical shape and plays a key role in how the pump works. I'll make sure to clean it up thoroughly with sandpaper. You can see these two guide pins here. They help position the ring precisely on the housing. And the O-ring seals camring. This is the outlet plate with two channels designed for oil to exit the pump. Right here you can see the coupling area where the pump connects to the electric motor, and this splinted shaft directly links to the cartridge and drive the vanes inside. Time to clean the cartridge and check if it runs smoothly. They're jammed up more than I thought. Look, all the grooves are the same size and fit perfectly. That inner spline, it's where the drive shaft goes, the one we checked out earlier. Let's drop the vanes in, one by one, nice and easy. The vanes should move freely in their slot. If one doesn't go in easily, just try another slot, it might fit better. This last one is a bit stuck, no big deal. We will just smooth out the edges with some fine sandpaper and it should fit right in. Only the edge, that's important, just the edge. See, it dropped right into place and all set. Just need a bit of fine sandpaper, preferably P240. Notice, because of elliptical shape, one side is open, other is closed. Alright, let's go over it one more time to really understand it. The cartridge mounts onto the spline shaft. Now I'm going to rotate the coupling by hand. Watch closely. These vanes that are now pushed out and touching the inner wall as the pump spins, they draw oil in through the inlet plate and these two ports right here. The fluid enters through these grooves. You can actually see the cartridge from inside inlet slots. As the pump spins, it scoops the oil and pushes it toward the narrow side of the elliptical chamber, where the space gradually closes off. And once the chamber becomes sealed, the fluid has nowhere to go. So what happens? It has to escape. And where does it go? Right here, this passage here. This is the outlet pass. Take another look at cartridge spinning. Since the motor runs much faster than my hand, the centrifugal force pulls the vanes right out of those slots it's on. There is also a thin cushion of oil that builds up inside the slot right behind the vanes, which help them move more smoothly. Now in some other designs they even use a small spring inside the slots, especially when the motor runs slower and there is not enough centrifugal force to push the vanes out. The equalizer holes which help balance the pressure, and this is a main inlet where the fluid gets drawn into the pump. There are also two guide holes here, as we mentioned earlier. They help keep the plate aligned and locked in place. Now pumps can differ in design, sure, but most of them work on similar principles. If you open up one and study it, you will get a solid technical understanding of the rest. Okay, time for a test run. Oh, a little engineer is back again. Go ahead and start it up. That's the output. The pump is working. See that? Oil is flowing right through the hose. The container is small, so I have to stop it here. Okay, shut it off. This was just a quick excuse to make a video and spend a moment with you. Stay safe out there.